a mission to Mars. We really want to develop materials that will be able to protect astronauts both on the way and while they're on the surface of the planetary surface. And these advanced nano-structured materials require science that we don't have yet. So that drives a need for a scientific understanding in how homogeneous gels can be created and how we can control that through the processing of these materials.
Inside Science.
So there are a lot of challenges to working on Mars. The Martian dust, because there isn't a lot of erosion, is extremely sharp. So you have very sharp sand-like particles everywhere the dust gets in everything. And that dramatically degrades the soft goods, the habitats, the spacesuits. The science was all about nanoparticle systems that form homogeneous gels and how we can study the aging behavior of those gels, how their mechanical properties change. The example of the sunscreen is a great one, right? Because you've got a material, and as it ages, the structure that was put into that to keep it as a cream and a homogeneous material with a nice yield stress starts to collapse and fall apart. And hence you get a liquid layer and it separates. And now when you put it on your skin, you're also not necessarily getting the coverage of the nanoparticles that are absorbing the UV. So the particles in the sunscreen are actually very similar to the particles that we were studying in our work. You get the aging right, as we've shown, you can actually strengthen the material with time. Think of it as a nanocomposite where we take the existing or best suit materials that we can make now in terms of textiles and treat them with these nanoparticle gels in such a way that they dramatically work synergistically to reinforce each other. And we've shown this in the laboratory. We're demonstrating this on the International Space Station. The low Earth orbit environment is actually a very hostile environment. There's extremes of temperatures. There's also, because we're at the very top end of the atmosphere, there still are oxygen radicals, which are very corrosive and reactive. And occasionally there are micrometeoroid strikes. The International Space Station is armored in many different ways to protect against that. And this is a candidate material for doing that. So we will deploy various types of formulations of our configurations that would be used in the outer part of the Martian spacesuit to put that at the front end of the International Space Station on a test station called MISSI, which is a materials test station designed to expose things to this environment, and then it will be brought back down to Earth for further diagnostics and study. And partly we just want to prove out that these materials can withstand the tremendous rigors of low Earth orbit. Obviously that's a different environment than on Mars, but can't test it on Mars till we get there.
Inside Science. If you enjoyed this edition, follow us on the web and social media. Powered by the American Institute of Physics and a coalition of underwriters.